In this video, we are going to discuss Yagi Uda antenna. What is the importance of Yagi Uda antenna? How to design an Yagi Uda antenna? All the things we will cover in this video.
First, let us see here. Today we discuss regarding Yagi Uda Antenna. I think everyone has seen this antenna in 2000 or previous years in your childhood. For example, if you the TV want to come means compulsorily the antenna is you have seen everywhere in the olden days for a TV reception. Okay, if you want, okay, compulsorily on the house of your house, this antenna is there. Okay, this is the antenna we have seen in our olden days. Now these are replaced by parabolic antennas, but in olden days, the very very famous antenna that is mounted on top of every house, mounted on top of every house for TV. Okay, so this antenna is called as Yagi Uda antenna. Okay, now let us study what is the brief introduction regarding this Yagi Uda antenna. So coming to the Yagi Uda antenna. So Yagi Uda antenna was named after two scientists. One is from Japan and one is from US. So initially, Professor S. Uda, Taro Uda, is from a Japanese scientist. Okay, who has explained the theory of this antenna in Japan language in the year 1928. Okay, in the Japan language in the year 1928. Later, the Japan language is not well known for all the people. The next Yagi, another scientist Yagi. Okay, so he's a English scientist. He translated that explanation into English, which made the world famous. Which made the world famous. So two scientists, namely Oda, who is a Japanese scientist, and Yagi, an English scientist. Based on the work of these two people, the name has came as Yagi Uda. Yagi Uda antenna. Okay, so these are the two scientists behind the invention of an antenna, what we see in our olden days. Okay, so now let us see here what is the purpose of this antenna and so Yagi Uda is an antenna that is well known for its high gain and direct. So the main purpose of this antenna is it is used to get the high gain and okay, so where these are this antenna is designed to operate at very high and ultra high frequencies, and the frequency range is from 30 megahertz to 3 gigahertz. 30 megahertz to 3 gigahertz. Okay, so see here, very very important. This is the structure of the antenna. Okay, so in this Yagi Uda antenna mainly consists of three parts. Yagi Uda antenna consists of three parts. The first part is a reflector. Second part is driven element, and third part is directors. Okay, so in any Yagi Uda antenna, we have only one reflector. We will have only one driven element, but we have one or more. We have one or more directors. One or more directors. Okay, so if you observe this diagram, so in this diagram, this is having the highest size. Okay, so it is called as reflector. Okay, next this is our driven element. This is our driven element, and remaining these two are called as directors. Okay, and remaining these two are called as directors. Okay, so the highest one are occupying higher size. It is a reflector. Next driven element, and these are mean. For example, if you take this, this is my this is my director. This is my reflector, and this is my driven element, and all these are directors. Okay, so if we observe, we will connect our coaxial cable. Here is our TV will be there. TV and this antenna is connected by a coaxial cable with the driven element. This is called as driven element. This is called as driven element. This is the active element. In this antenna, in this Yagi Uda antenna, it consists of both active parts and passive parts. So in this, what is the active part in the driven and the Yagi Uda antenna? Driven element is the active part. Active part. Okay, so due to excite of this, the remaining elements will also get excited. That's why the directors are called as passive parts. Directors are also called as passive parasitic elements. Parasitic elements. Okay. So it is a combination of Yagi-Uda antenna is a combination of both active and parasitic components. So what are the parts of an antenna? Reflector, driven element, and directors. One or more directors. So in an Yagi-Uda antenna, we have only one reflector, one driven element, but one or more directors. One or more directors. Okay, so it is an array of active and parasitic elements. It is an array. So this is a reflector, this is a driven element, and these three are directors. These three are directors. Okay, so this is the middle one, driven element or the type of is generally a metallic rod having an active element. This is the active element which is used for external fitting is provided to using transmission line. While reflectors and directors are parasitic elements. Okay. What is meant by parasitic elements? They doesn't uh, get excited. They will be get excited by an active element. Okay. So the parasitic elements are also metallic parts. Here, what are the parasitic elements? Director and reflector are the parasitic elements. Okay. So parasitic elements are the metallic parts paired spatially in the line of sight with respect to the driven element. Okay. So for parasitic elements, there will be no external excitation. Okay, no external excitation. It doesn't provide any external excitation. However, the parasitic elements will get excited by the dipole. Okay, driven element. Okay, so this is the structure. Okay, so it is a combination of both active and parasitic elements. It is a combination of both active and parasitic elements. Okay, so let us see how what is the working of Yagi Uda. Okay, so we know that the external excitation is directly provided to the active element. Active element means driven element. That is for dipole. Okay, so the flow of the current to the active element, as I have told that only the active element is driven element and remaining all are parasitic. Okay, we are not providing any excitation for remaining elements. We are providing the excitation only for the driven element. Okay, so the flow of current through the active element induces a voltage in the parasitic element that causes the current to flow through this. Okay, so the element having a length greater than lambda by 2, that is the reflector. Okay, so see here in this structure, in this structure, for example, if this is my structure of this antenna, so this is my reflector. Okay, this is driven element. This is my driven element, and all these are directors. These are directors, driven element, reflector. Okay, so here driven element you are taking the length it as lambda by 2. Lambda by 2 means nothing but 0.5 lambda. Okay, and reflector. So if you observe in this diagram, the reflector is more when compared to the reflector size is greater than 0.5 lambda, and the director length is less than 0.5 lambda. Director length is less than 0.5 lambda. Okay, so the element which is having greater length lambda, that is reflector, shows which characteristics? Inductive characteristics. Therefore, the current in the reflector lacks the induced voltage. Whereas one shorter than the half wave dipole, that is the directors is, what is the property of the directors? Capacitive. So here current leads the voltage. The previous case, current lacks the voltage in a reflector since it is greater than lambda by 2. Since the directors are less than lambda by 2, it is capacitive. What is the property of capacitive? Current leads the voltage. Okay, so the director is placed in front of the driven element, so the directors add the feed, okay, of the driven element. Okay, so and are placed in the arrangement, then each director will provide excitation to the next one. Okay, so what is coming to the operation? How the operation coming to the operation? So see here, coming to the operation. How the operation of this is, for example, this is my reflector. This is my driven element, and all these are directors. These are directors. This is driven element. This is reflector. Okay. If any radiation wave is coming here, okay, these directors will observe and direct it to the driven element. And if any signal is moves out of this, okay, the reflector again observes this and again transfer to the driven element. So here we'll get a group of bunch of radiation element that is given to our TV. Okay, so this is the working principle of the antenna. Okay, so coming to the characteristics of Yagi Uda antenna. Yagi Uda antenna is said to be the beam antenna. It's only of three elements array: a driven element, a reflector, and only a single director. Okay, so if you take three elements, if you take, for example, if a Yagi Uda antenna is four element antenna, what are the, tell me the parts? Four element antenna. What are the parts? We will have one reflector, one travel element, and two directs. Okay, for example, if it is a five element diode, tell me the parts. We will have only one reflector, one driven element, and three directors. Three directors. So we will have three directors. Okay, so in order to increase the directivity, more elements can be added to the another name of this antenna is superdirective antenna, which is high directive. So it is frequency sensitive, that is fixed. Okay, so this is the radiation pattern. So if I draw the diagram here, if I draw my diagram here, this is my driven element, this is my driven element, and this is my reflector. This is my reflector, and these are all my directors. Okay, so the maximum radiation is along the directors, and minor loops are along the reflector. So this whatever the radiation absorbed by this all will be forwarded in the director's direction. Director direction. Okay, so advantages of Yagi Uda. Yagi Uda antenna offers very high gain. It possesses highly directive characteristics because the use of directivity is a low cast antenna. Yagi Uda antenna shows suitability towards high frequency operation. It is light in weight and feeding mechanism is also simple. It is power efficient. Along with all the above point, it also offer use of construction and handling. What is the disadvantage? These antennas are highly affected by atmospheric conditions. Noise is the major factor that disturbs the overall performance of the. So where you are supposed to use? You know that everyone we are using this antenna for the main purpose is for TV reception, TV signal reception and